In this lesson, we are going to talk about slope and rates of change. When we're comparing lines, it's helpful to compare how steep they are. So let's make a quick line. I'm not even going to put it on a set of axes. Here's a line. Here's a line. Here's another line. And here's another line. Okay, so we have 4 different lines here just floating around on the page. How could you possibly compare these? Are they the same? Are they different? Are they similar? Well, we could look at how steep they are. So which one is the steepest? Maybe the pink one right here. It goes up very quickly. This one's also very steep, but in a downwards way, in a negative slope. This one's less steep. And the purple one in the middle is the least steep of all. It's actually really close to flat. Okay, so I'm using things like biggest, smallest, I'm trying to compare them, but really we need a more mathematical way to compare the slopes. We need to be able to find a value, find a formula. So we define the slope as the change in the y values over the change in x values. That's a lot to write, isn't it? Well, lucky for you, there's a short form. For change in, we use this triangle shape. It's called a delta. It's a Greek letter. Delta y over delta x. Change in y values over change in x values. So we can look at the graph and let's pick a couple of points to work from. We can pick any 2 points on the graph at all, but it's helpful if you can find points that go through a whole number, a square on the corner of the grid. It is very helpful. And we are going to look at the change in y values. How much did that change by? It's going up 2, positive 2. And the change in x values. The x value is increasing by 1. Positive 1. It's increasing by 1. So for this question, the slope is equal to 2 over 1. Oh, we can simplify this. Anything divided by 1 is itself. Now you might be asking, how did I know to pick those 2 points? What if you picked the wrong 2 points? Well, there's actually no wrong points. Any 2 points on the line, if you take the change in y over the change in x, you'll always get the same value. Don't believe me? So let's do this together. Let's do a big, huge change in y. So this increase is from 0 all the way up to 10. It's increasing by 10. And the x, is up to 5. Okay. So now this time when we do the slope, we get 10 over 5. Ooh, 10 over 5. Is that different? No, 5 goes into 10 twice. So we still got m equals 2, a slope of 2. Now, one more way that I want to just add one more thing here. Change in y over change in x. We also call this the rise over the run. Oops. The rise, that makes a lot of sense. Notice how we did these lines going up and down. We said it's going up by this much. So rising, that makes sense. Run can be hard to remember run. Doesn't seem to make a lot of sense. I like to think about it like you're running along a horizontal surface, just like you are outside in your running shoes running along. So the run is on a horizontal, it's the x, the change in x, and the rise up and down, like the change in y. So we found the slope. Now remember, we talked about equations in the last lesson a little bit, and we said if it is direct variation, is this one direct or partial? Oh, it goes through 0, 0. It's direct. If it's direct variation, the equation looks like this, with the magical little m there. Well, that m is the slope. So the equation for this line is y is equal to 2x. And you can make sure that that's right. Let's think about some x values. Sketched out a little bit here. So if x equals 3, let's see what we get. So x equals 3, y is equal to 2 times 3 equals 6. Is that right? 2. So x is equal to 3, and we get 6. Yep. So right there, 3 comma 6. This is x equals 3, y equals 6. Perfect. We found an equation, and we checked it. Sometimes you might be asked to do a formal check. Same idea as this. You just actually write the word check. Okay, let's do another example. So remember our formula? We can write it how we want to. M is equal to rise over run. Slope is equal to rise over run. Do you like writing it that way? You can also write change in y over change in x. So change in y over change in x. I've got lots of nice spots to do this. Nice whole number points. So the change in y over here, change in y is equal to, well, I see 2 squares. That's great. 2 squares. This isn't perfect. Have a look. What's wrong? Well, the line isn't going up 2. The line is going down 2. How do we show that it's going down? Negative. It's decreasing by 2. Now let's do the change in x. So we start over here and we go over. The change in x is also 2. Do we need to make it negative? Well, negative would actually mean moving in this direction. And we didn't. We moved in this direction. And you look down here, you go from 1 to 3. It's a positive move here. So what's the slope? Negative 2 over 2 is equal to negative 1. So we found the slope. Do you think we can find the equation? Let's give it a try. So is this direct variation or partial variation? Well, direct variation goes through, the origin goes through 0, 0. Does this go through 0, 0? No, of course not. So it must be partial variation. In the last lesson we said y equals mx plus b is the equation for partial variation. So the slope, do we know what the slope is? Yes, we sure do. It's minus 1. B. What's b? Maybe you remember what b is, maybe you don't. So if you don't remember what b is, let's try to figure out what we need to add on to this equation. So we already know, it's always helpful in math, write down what you know and then figure out what you don't know. So we know the equation is going to look something like y equals negative 1x plus b. I'm just not sure about b yet. We haven't figured that out. Maybe you know, but I'm going slow for everybody. So let's sub in what we know. We have a point here. We have 0, 10. 0 is the x value, 10 is the y value. This is a great trick. Writing x and y above really helps. So we're going to sub those values into the equation. 10 is equal to negative 1 times 0. Well, anything times 0 is 0. So 0 plus b, 0 plus b, anything plus 0 in it's itself. So b is equal to 10. B is equal to 10. Oh, that's right. B is the y-intercept. So we have everything we need to put the equation together. Y is equal to the slope times x plus the y-intercept. Okay, one little thing we can do to make this look a bit nicer is we don't need to write the 1, we can just write negative x plus 10. So we're going to work with the equation of the line so much in this course, over and over and over again. It's very important that you remember y equals mx plus b. M is the slope and b is the y-intercept. We can also do this one more way. We can be given points. Actually, two more ways. We could be given points and we could find the slope. So we've been kind of doing that here. We've been looking at 2 points and then we've been finding the slope. Let's see what that would look like if you were given points. So what would this point be? It would be 1, 9. And this point is 3, 7. Okay, so I just told you you could be given 2 points and you can find the slope. How so? What do you have to do if you have only these points? Only 1, 9, 3, 7. If you had only these points, how could you find the slope? Well, we changed from 9 to 7, so we went down 2. But why down 2? Let's work it back a little bit. 7 minus 9, and we went over 2. We went from 1 to 3. So the difference is like this. Negative 2 over 2. We're going to do an equation. One more equation for the slope. Do we have any space anywhere to write one more equation for the slope? Let's just put it in here with all the other equations for slope. So we did the 7 minus the 9 over the 3 minus the 1. It's kind of confusing to have 2 points. I can't say like y minus y over x minus x. That doesn't make a whole lot of sense. So we're going to have a point 1 and a point 2. Point 1, x 1, y 1, x 2, y 2. Okay. So we did 7 minus 9, that's y2 minus y1, over x2 minus x1. So if you're given 2 points, you can just label them. The first point is x1, y1. The second point is x2, y2, just like we've been saying x comma y, x position, y position. This just lets us identify that this is point 1 and this is point 2. And you just sub it into the equation. Most people find it really helpful to write over top of the point x1, y1, x2, y2. You've got 4 different things here. It just helps you to keep it straight and to make sure that you put the right numbers in the right place. We'll do more of that later. Another way you can find rate of change is being given a table of values. So you could be asked to find the slope or the rate of change given this table. You could graph the table and then you could find the slope, but that's a lot of unnecessary work. Instead, we can think about what we did on the other page to figure out the slope. Remember that the slope is equal to change in y over change in x. So we are going to look at these y values. We're going to do the second one minus the first one. 4 minus 2 is equal to 2. I didn't write anything on the bottom. Oops, should I put something in there? 2 minus 1. Oh, well, 2 minus 1 is just 1, so that didn't make a difference. Usually in a table of values, we go up by 1, unless there's some kind of funny scale in an application question. So as long as the x values go up by 1, you don't actually have to divide by the change in x values because it's just 1. Okay, notice here 6 minus 4. 6 minus 4 is equal to 2. 8 minus 6. 8 minus 6 is equal to 2. Oh, look at that. We got 2, 2, 2. Remember what we talked about before when we were looking at the graph and we found the slope in more than one place? That the slope, or the rate of change, it stays the same throughout the whole graph. That's important. That actually defines a linear relationship. The rate of change is constant. The slope stays the same for everywhere on the line. If it didn't, it would mean something like, well, we start off a graph. That's not such a nice color here. We start off a graph, and at first the rate of change is always the same, and then it starts increasing, and the y values start increasing more quickly than the x values. Well, that is not a line. That is not a linear relationship. And in this case, the slope is not the same everywhere. So this is not a line. If the slope's the same everywhere, it will make a line. Okay, so we talked about the equation for finding the slope. You're going to memorize this. You're going to use it over and over again, and you're going to try your best to memorize it. So we have the equation. We can find the slope given 2 points. We can find the slope given a graph, or we could find the slope given a table of values.